Hey Lee, so today we're starting chapter 10, so this is our second last chapter. So I'm sure you guys are probably starting to get pretty excited here, almost done the course. Congratulations, we made it this far. Alright, so chapter 10 is going to be all about function operations, and so basically we're going to be looking at system of equations and manipulating them using operations. So you guys know your typical ones are usually your adding, subtracting, multiplying, and dividing. So we're going to be looking at that throughout this whole chapter here. And just as to note here, once again, you guys have probably heard this 1,000 times. From here on out, our chapters are pretty short, so just keep an eye on these short deadlines here. Within 6 days, we're going to have an assignment and a test coming up here pretty soon, so it will go by pretty quickly there, okay? And just one key term that we're going to be looking at in this function is a composite function. This is until our last lesson of the unit, so you guys won't have to worry about that just yet. We're just going to be focusing on just the basic operations until 10.3. So to start here, section 10.1 here, we're going to be looking at the sums and differences of functions. And so if you guys should hopefully know what those terms mean. So basically what we're going to be looking at is a system of functions, and we're going to be adding and subtracting them, okay? So to start off here, so by performing these operations on these functions, such as multiplying, dividing, adding, and subtracting, we can create new functions. And in this section, we are just going to specifically be looking at what happens when we apply sums and differences to functions. So don't overthink this, it's exactly as it sounds. We're just going to be adding two functions together or subtracting them, and we're going to be graphing what the result is, okay? So the sums of functions, so suppose we had two functions, f of x and g of x, and suppose we added them together to produce some sort of function, h of x. So the result there is h of x, okay? And so we can rewrite what this h of x is. We can represent it in two different ways, and they mean the exact same thing, but you just might see this notation depending on, if you're moving on to a different, say, university or something, you might see it in two different ways. So I'll expose you to both of them now, so that way we can get used to them, and it'll help you a little bit later on, okay? So the first way we can represent h of x, first we can say we have f of x plus g of x. Okay, sounds pretty simple. Hopefully we can figure that one out. But this one here might be a little bit more trickier, but essentially it's saying the exact same thing. And so this one we just, in brackets, we have f plus g, so the functions f and g, and we're working with a variable x, okay? So these are both saying the exact same thing. We're adding two functions, one f of x, one g of x, and our result there is h of x, okay? So here I give you an example here. We have f of x is equal to x squared, and I also give you that g of x is equal to negative x plus 5. And simply what we're going to be doing is we're going to be adding those two functions together. So once again, do not overthink this. You're literally going to add x squared and negative 5 plus x. So adding f of x plus g of x, we have x squared, which is f of x, and negative x plus 5 there. And what our result is, apply this positive to our brackets so we can drop those brackets. And what we have is x squared minus x plus 5. Okay? So don't overthink it. You're literally just adding the two functions together. Okay? And so if I can pull your attention over to this wonderful graph here, this big parabola here, this is our f of x, that'd be x squared there. They're all labeled there, but just to help point them out there. And our straight line here, this is g of x, that's negative x plus 5. And this little tiny parabola just touching our line there, that one there is h of x, so that's our resulting graph. That one is x squared minus x plus 5. You guys can put this into your graphing calculators, check it out that way as well. And you guys should know so you guys get the exact same graph. And I just want to make one little note about the graph of, say, your two original functions, f of x and g of x, and the resulting h of x graph. If you were to take, say, two coordinates, one from each function, say we had, so I'm just going to give this in general, so say we had two functions, we had, say, x and y1. And I'm going to make this really important. Your x values, choose the same x values, but your y values are going to be the ones that are different. So say in our second function we had y2. the resulting function, say if we were to add them together, your x value stays the same and you would add the y values together. So y1 plus y2. Okay? So we can even tell what our new graph is going to be just by looking at that graph. So your x value stays the same and you're going to add the two y coordinates together. Okay? Let's look at an example. So let's even start with, let's go with x is equal to 0. So for f of x, 0 is at actually the origin there, so that one's very nice. We're at 0 and 0. And for g of x, that one's at 0 and 5. So then let's add the y values. So your x value stays the same, so we're at 0, and 0 plus 5 is equal to 5. Okay? So just add those two coordinates together. Okay? If you guys want to see a second example there, let's take x is equal to 1. So both of those coordinates there are equal to 1. So for f of x there, we have 1 and 1. And for g of x, we have 1 and 4. So what our resulting function is going to be is your x value stays the same, and you add the y value, so it'll be 1 plus 4. So you'd have 1 and 5, and you can double check this. Let's go to 1. Let's go all the way up to 5, and what a coincidence, it's at 1 and 5. So hopefully you guys kind of get that picture that you just add the y values together, your x value stays the same, and that is the resulting graph of the sum of functions. So moving on to the difference of functions. So suppose we had two functions, f of x and g of x, and suppose that we subtracted them and they produced h of x. Once again, we can rewrite this in two different ways, both meaning the exact same thing. So our first way of writing it there is h of x is equal to f of x subtract g of x. Or we can write h of x as equal to, in brackets we'll have f minus g, and we're using the variable x there. Okay? So they mean the exact same thing. We're just saying that we're subtracting function f of x and g of x, and our resulting function there is h of x. Okay? So looking at an example here, here we have f of x is equal to negative 2x, and we also have that g of x here is equal to x minus 4. And our resulting function, we want to find h of x, where we're subtracting. We have f of x minus g of x. And so you're literally just going to subtract the two functions. So you have negative 2x, which was just f of x, subtract g of x, which was x minus 4. You're going to distribute your negatives, so you'd have, if I could write out this little in-between step there, would be negative 2x minus x plus 4. And what you're left with there is, when you combine your like terms, we have negative 3x plus 4. Alright? And so I gave you a bit of a different graph here. I didn't like the one from the textbook that I borrowed, so I made my own graph here. You guys should recognize Desmos by now. And so here we have f of x is this line that's decreasing right here. And g of x is this wonderful increasing line here. And our resulting function here is blue. Yours will probably be black and white, so you guys can't see that. But this here is h of x, where that is negative 3x plus 4, sorry there. Alright, and so if I can draw your attention once again to those coordinates, what happens when we subtract those coordinates or those y values? So what we're going to have is we're going to have that resulting function where we subtract the two y values. So let's do an example here. So this one's going to be a little bit harder. We don't have as big of a window here to look at, but let's look at, say for example, let's look at x is equal to 1. So there we have x is equal to 1 for both of those coordinates. And so for f of x there, when x is equal to 1, we're at negative 2 there. And when g of x is equal to 1, y is equal to, that's negative 3 down there. And our resulting function, so our x value stays the same, and we subtract our two y values there. So negative 2 subtract negative 3, that is negative 2 plus 3, and we're left with positive 1. So let's look at that on our chart. Let's find x is equal to 1, and as if we could have predicted that, or as we calculated, x or y value there is 1. And you guys can do that if you guys put this into your graphing calculator. You guys can test this out, change your windows, but this should work for any point. So just make sure, if I can make one really strong important note here, it must be f of x subtract g of x. So here if we had f of x, it states here f of x comes first, then it's g of x. If I can make this even stronger, 4 minus 2 is not the same thing as 2 minus 4. Those are not the same thing. So it's really important that you have your order correct. So if it says f of x subtract g of x, you take your f of x coordinate and subtract g of x, so that's second coordinate. So you have -2 subtract -3. If we were to do that the other way around, we get -1, and that is not the same thing, okay? So order, especially with subtracting, is very important. So please keep that in mind when you guys are completing these examples and the questions, okay? So moving down to, let's talk about, just quickly, a little note about the domain and the range. So suppose we had the domain of f of x, and this one I just made up just for example's sake. F of x here is that x must be greater than or equal to 0. And suppose we also had g of x was that x had to be less than or equal to 10. And so what the resulting domain is for h of x is whatever is in common with both of those domains. So big key there is where it overlaps. So I'm going to draw this onto a number line there. Just hopefully it'll help you guys see what's going on here. So for our first function here, f of x, this one must be greater than or equal to 0. So it starts here and it'll keep on going. These are all the values that are allowed for f of x. And for g of x here must be less than or equal to 10. So we'll put 10 over here. So it'll start at 10. It has to be less than. So we're going to keep going in this negative direction. And that's for g of x. And so what our domain for h of x is going to be this overlap. So starting with, it's going to be at 0. And it's going to go up to 10. So it's where that overlap is. Okay? So if we were to write the domain for h of x, your domain is x such that, so it must be greater than or equal to 0, but it also has to be less than or equal to 10. And don't forget that x can be an element of all real numbers. Okay? So it's where that overlap is. So if both functions cannot go, or if one function can't go above 10, then that means h of x can't go above 10. And you guys can, try this, play around on your graphing calculators and prove this out. You can take two functions, maybe even take, say, the square root of x, this one here. X must be greater than or equal to 0, and then you can take, say, a regular function, say y is equal to 2x. And what you'll notice is that wherever that overlap is between the two domains, this one here is x is an element of all real numbers, so that overlap is where your domain is going to be for your h of x. And if you notice, that overlap will simply be x must be greater than or equal to 0. So test it out into your graphing calculators, but we'll also see some examples later on, either in the section or later on in the chapter. And hopefully that'll help prove that point there. And just as one note, your range is a little bit more difficult to talk about. And so if you guys just graph it, it'll be a lot easier to just graph it and determine your range from there, okay? So let's look at some examples in the next video. We're getting close to our 50-minute mark there, so we'll switch on over and we'll start completing some examples.